Okay, so this time we're going to be going through quite a few symbols that are usually used for various different types of dimensions. Now before that, I want to mention one special thing. So we have dimensions, and you'll see them something like this. Like so. Usually filled in head. Every once in a while, you'll see this in parentheses. And what that's talking about is this is a reference dimension. It's more or less the person might be worried that you're not good at math. And so they decide, you know what, I'm going to give you a break, and I'm going to tell you what this dimension is, so you don't have to do math. Now, this doesn't control the part. It's not saying that, if this is not exactly 5, you fail. It is just helping you do math. So if you had a part that looked like this, and you have 2 dimensions, maybe one like this, that's 3. Forgive this terrible writing, it's just being simple here. And this one's 2. Well, everything's based off of those. Maybe they have their own tolerances and their own feature control frames constraining them. But then maybe the person is, well, maybe they don't know how to add, or you just want to make it easier on them, because sometimes this is very, very helpful. And they'll say, okay, 5, but they'll put it in parentheses so you know that's just there for your reference. It's not meant to control anything. Just meant to remind you that 2 plus 3 is 5. Parts get really, really complex. You can sometimes need reference dimensions, especially if you have a whole lot of different, planes going down. With all dimensions for all these, you might want to give them, well, what is the sum of all those, just to save them some time. Remember, it doesn't actually create a requirement for acceptance or rejection of the part, okay? It's just there to be nice. Okay, now let's look at a bunch of different symbols. So first off, we have the arc length symbol. It's used when you have an arc, like this, a section of a circle. And it tells you how long that section is. The surface, not the chord. We have the square symbol. This is when your cross section is square, like so. You want to show that in a single dimension, because otherwise you would have had to do 2 dimensions, and that is just wasting people's time. So we use the square symbol and say, okay, both sides are going to be 0.38 with the length and the width and the height. However, this does not imply a tolerance on 90-degree angles, which are forming the square. That would have to be given somewhere else. The slope symbol, if I have an angled place, I can give the slope. And it gives it to you as a change in surface height per unit of distance. It's always rise over run. Rise over run along some baseline. And the slope value is always placed before the tolerance. Now, I don't see this too terribly much, but you might. I normally see people show an angle, but you can still see the slope symbol being used, so keep it in mind. And then taper symbol. Now this one I see a lot used a lot more often. So taper is going from a certain cross section, usually circular, and it's tapering down like with a cone. In that case, you could give the angle, or you might want to just say what fraction it is. It's going to depend on your particular use case. If it's really, really long, it might help to give the slope rather than the angle, just because this will make more sense. Then they can say, okay, well, I've gone 10 feet. And this is rise over run, so I've gone down 1.8 feet. Helps for very, very large items. Origin symbol. Now, this is for applications when it's necessary to indicate the origin of a dimension. And while it looks like the symbol is this, it is not. The symbol is just the circle that is pointing to say that is where this dimension begins, and it goes up from there. So you have an arrow on the other end, you just don't have one at the beginning. Now, why is this? It's most likely because this is where they want you to start measuring from in this particular dimension. Okay, that's where they want you to start measuring from this particular dimension. It's not one of those either or, like I can do it from here or I can do it from here. Or saying, well, I'm just going to put a little vise on it and measure it like that. No, you're starting here and then measuring that direction. It might be for repeatability. It might be because of just how the feature is defined. Perhaps it's very difficult to grip this side, and this is the point where you want to go from. Or maybe this has a very strange profile. There's lots of reasons why you could have that origin symbol. But when you see it, that's where you start measuring from. So that's it. Remember, you're not expected to be suddenly masters of all these symbols. You're just more or less supposed to remember, oh, okay, that was the taper symbol. If you see it again, you'll know what symbol it is. If I ask you to on a problem, you'll say, okay, he's asking for taper. You go look in your textbook, you find the taper symbol, and then you use it. We're going to have application problems this chapter, so make sure you're getting ready for those by knowing how to use your textbook as a reference. Thanks for listening. See you next time.